Hi Advanced Trig students, this is the first time you'll get a sub video from me when I happen to not be at school. So we're going to be working a little more on these 6-1 notes. I got a lot of stuff I need to add to it to help you out. And again, some of this is review to some of you, particularly if you were in the honors class. And if you weren't in the honors class, I'm going to go through it in such a way that hopefully you'll be able to have an understanding of what's going on. If you feel like you're getting a little lost, maybe find someone else at your pod who can help you out. But I think I've got a way to introduce this so everyone's on the same page. Yesterday, in section 6.1, we talked about a new unit of angle measurement called the radian. And it is a little more exact unit of measurement, and the reason for that is because of the pi symbol that's in it. So we learned how to convert between degrees and radians and degrees. To convert between degrees and radians, if you want to change 45 degrees to its radian measure equivalent, you multiply it by pi over 180. Now, these are just two fractions being multiplied, except we're not going to put the pi symbol in our calculator. We're going to ignore it for a second, and we're actually just going to reduce this part of the fraction. In the graphing calculator, you can reduce the fraction by typing in 45 over 180 and hitting math, enter, enter, and it'll tell you 1/4. So pi over 4 is the radian name of 45 degrees. If you want to go the other direction and you know the radians, but you want to know what the degrees are because degrees make more sense to you, we would multiply by 180 over pi. What ends up happening is the pi's cancel, and when you multiply the fractions together, you get 180 divided by 6, which is going to be 30 degrees. These angle measurements, we're going to equate them to a circle on the coordinate plane. So this circle has a special name. It's going to be called the unit circle. And the first angle, you know that angles are created by two rays with a common endpoint. Well, the ray that we always start with is going to be one that's on the positive x-axis, and we call that 0 degrees. We go around counterclockwise to go to other positive angles because there'll be positive angles and negative angles. I don't know why counterclockwise is positive, because it seems to me that clockwise should be positive, but you know, I didn't create this stuff. So the other thing that we talked about was that because the axes are perpendicular to each other, they create 90-degree angles. So if this were your terminal ray, you would have a 90-degree angle. If this is your terminal ray, you'd have a 180-degree angle. Remember, 180-degree angle is a straight line. And then the negative y-axis would be 270 degrees. One of the things that's sometimes hard for students to understand is that, yes, we can have angles that are bigger than 180, because in geometry you couldn't. And then once you complete your circle, you're back at 360, and I want you to notice that 0 and 360, their ray land in the same location. Keep that in the back of your mind for just a moment. The other thing that we did was we talked about the radian equivalent of these. Now, you can always go back and use the conversion formula for converting between degrees and radians, but we said that 360 is 2 pi radians. That means 180 degrees must be 1 pi because it's half of it. And since 90 is half of 180, we said that 90 was pi over 2, or half a pi. And then 270, very interesting. A lot of people thought it was 3/4 pi. And that was a great reasoning skill, because you said, wait a second, that's 3 out of the 4 little pi pieces, isn't it? That's not the right answer, but it was wonderful reasoning skills. It turns out that it's really a pi and a half. So, you know, you go half a pi, and then another half is 1, and then another half is 1.5. And 1.5 is also known as 3/2, so we call this 3 pi over 2. 0 degrees, by the way, is just 0 radians without the degree symbol. Now, let's go back to this for a moment, specifically. Remember I said that 0 degrees and 360 degrees landed in the same location? That's because they have a special name. They're called coterminal angles. Coterminal angles are angles whose rays land in the exact same spot. So this one here at 90 can have another angle name as well. Because here's the thing. Turns out you can go around in a circle more than once. So let's go to the next page here. Blank circle. So let's say that I start here at 0. And then I go around in a circle. So I've gone 360 degrees. But what if I go around in a circle again? I'm really adding another 360. So 360 plus 360 is 720. So 720, its ray lands in the same location as 360, which lands in the same location as 0 degrees. When you have different angle measurement names for the same ray, we call them coterminal angles. Coterminal angles are really easy to find. So let's go look at example 2a real fast and do this in degrees before we do it in radians, because we have to do a little more manipulating when we find coterminal angles in radians. So in example 2a, I want to find some coterminal angles with 62 degrees. So the first thing that I'm going to do on this little circle is I'm going to guesstimate where 62 degrees would be. Well, if this is 0 and this is 90, then 62 must be somewhere in quadrant 1. So I'll call this 62 degrees. Okay, so a coterminal angle is another angle name for the same ray. And the way that you get to it is by going around in a complete circle. So if I start at 62 and I go around in a circle, where am I at now? Well, you just added a circle. That's adding 360. So we would do 62 plus 360 is going to be 422 degrees. So this is one coterminal angle of 62 degrees. Here's the thing though. I said counterclockwise is a positive angle direction. You can go the other way in a circle too, and we call those the negative angles. So if you go around instead this way, we would call this down here negative 90 degrees, because you'll have gone 90 degrees, it's just you went in the other direction. So that means we call this negative 180, and so we're going to call this negative 270, and then we're going to call this negative 360. That's the only difference. So what if instead I start at 62 degrees and I go the other direction in a full circle? Instead of adding 360, I'm subtracting 360. So 62 minus 360 is going to be negative 298. So negative 298, 422 are both coterminal with 62 degrees. Now, there's an infinite number of coterminal angles. We could keep adding and subtracting 360 forever if we wanted to. It's just that we don't need to. It's best to just find one positive and one negative coterminal angle. All right, let's go do this again, except we're going to use radians. And it might help if we change those radians back to degrees, because that'll tell me where it is. So the first thing that I'm going to do is I'm going to multiply 5 pi over 6 by 180 over pi and change it back to degrees because I understand degrees. The pi's cancel, so you're left with 5 times 180, which is 900 over 6. And 900 over 6 is 150 degrees. So I know that 5 pi over 6 is the same as 150 degrees. So now I know where it is. So here's my circle. And if this is 0 and this is 90, oops, almost right, 150, 180, 270, 360. Then 150 must be somewhere in quadrant 2. Remember, this is 1, 2, 3, and 4. So 150 is going to be over here somewhere. Now we're really working in radians. I just wanted to change it to degrees so I could figure out where it was. Here's how it works. When you go around in a circle counterclockwise, that's the positive direction. So we're going to add 360, except what did we say 360 was in radians? We said it was 2 pi. So we're actually going to add 2 pi. But how am I going to do that on my calculator? So here's the trick. You're actually going to ignore the pi, and you're going to do just 5 over 6 plus 2. So if you do 5 over 6 plus 2 in your calculator, and then you hit math, enter, enter, it'll change it back to a fraction, you get 17 over 6. And then all you need to do is tack on the pi. 17 pi over 6 is another name for that blue ray in quadrant 2. So now what happens if I go the other direction? If instead I start and go clockwise, we said that was the negative direction. So instead I'm going to subtract a circle. And in radians, a circle is 2 pi. To do this in my calculator, I'm going to do 5 over 6 minus 2. And then I'm going to hit math, enter, enter. And it tells me that it's negative 7 over 6. And I'm just going to add the pi there. And that's 1 positive and 1 negative coterminal angle for 5 pi over 6. We're going to do one more example, and then I'm going to give you some problems from the book to work on. I don't want to start on length of an arc because that's basically a different topic altogether. So let's do a little more with these coterminal angles. I want to find an angle with a measure that's between 0 and 360 degrees. That's coterminal with an angle of measure, and this is a correction. We should say 1,635 degrees in standard position. It says 163.5 on the paper. Well, 163.5 is already between 0 and 360, so that would be wrong. Okay, we're going to start with some huge angle. So we want to find a coterminal angle with 1,635. I don't know where 1,635 is. The only thing I can figure out on the unit circle is where an angle lies if it's between 0 and 360. So in order to figure out where 1635 is, I got to change it to a coterminal angle. Now, here's the thing. In order to find coterminal angles, you're either going to add 360 or subtract 360. Which direction do I need to go in order to get an angle between 0 and 360? Well, I'm going to subtract. Now, you may have to subtract more than once. I'm going to write this out. You probably wouldn't do it this way. You would just do it in your calculator. But I'm going to go, okay, I'm going to subtract 360. So I went around in a circle once, and I'm still not there. So now I'm going to do it again, and I'm still not there. And then I'm going to do it again, and I'm going to keep subtracting a circle. I'm going to keep going in a circle and stopping at the same place until I get a number that's between 0 and 360. So I'm not there yet. Let's do it one more time. And I bet I'm there. And I am. I'm at 195. The ray for 1,635 would be in the same location as 195. And the reason that's important is because now, knowing this is 0, 90, 180, 270, 360, and hopefully at this point in time you now have those numbers memorized, I can tell you that 195 is going to be here in quadrant 3. So I have a general idea of its location. And again, the way that these angles work, we always start with something called the initial ray, and the initial ray starts on the positive x-axis. The positive angle direction is always counterclockwise, which is backwards from what you might suspect it to be. And so that'll tell you what quadrant you're in. So quadrant 1 is anything between 0 and 90. Quadrant 2 is between 90 and 180. Quadrant 3 is between 180 and 270. And quadrant 4 is between 270 and 360. For those of you who did the unit circle in Algebra 2, and you were probably given a big sheet of paper with a big circle on it that you had to fill out, we are going to do it again, and we're going to work on memorizing it. So let me give you an assignment to work on in regards to this. So I want you to work on page 440, number 28, 30, 40, and 46. I know it's only 4 problems, but it's a little bit of work, and some of you may be still trying to grapple with the idea of a radian and putting a circle on the coordinate plane. So make sure that you're working with your pod and checking your answers with each other, and when I come back tomorrow, I will give you the answers. Have a great rest of your day. If you have any questions, feel free to email me.